All right.
So again, you got your positive cations. That's the positive signs up there. And then these negative charge, these negative things here are the electrons. They're buzzing around. Again, the analogy of like boats that are anchored, and then the water around them is the valence electrons. So sea of electrons, sea of mobile valence. That's like a term you can use on regions. And again, the biggest thing I want to stress besides that definition is this letter right here, A, one metal. So a piece of copper, a piece of iron, a piece of sodium, calcium, nickel, whatever, barium, whatever metal you want to talk about or picture, it is not multiple metals together. That doesn't happen. There's no such thing as bonding two metals together. That cannot happen. Okay, so this is one metal. It's being held together because it's attracted to itself. It's attracted to its own electrons. But because the electrons are moving, it can bend and it can conduct electricity. We're going to write that next, and I'm going to show you the video. So because there's movement inside the metal, so due to that sea of electrons, metals can bend, metals can conduct electricity. What else can it conduct? Heat. That's more because the atoms are so close together, the ions are close together. But I'm going to write why here. Why? Why can metals bend? Why can metals conduct electricity? Big one.
Yeah, I'll come down fourth period.
Yeah.
You're going downstairs.
Yeah, I'll be down there the whole time.
All right.
Metals can conduct electricity and heat. They can bend. Why? Because the mobile valence electrons, I think I keep spelling valence wrong every other time. Sorry, guys. You know what it is. Because the mobile valence electrons allow. All right. Let's say I'm a hammer, a giant hammer, sledgehammer. And you guys are a piece of metal. And I hit you with a force. What are you going to do?
Bend.
You're going to bend. How come you don't break?
And then metals.
Here's why. And then I hit you from the other side. And I bend you back. No, don't cheat, Sean. Okay? Like if you have a dent in your car, you can just take the door off and then bang it out from the other side, right? Do you know that or not? Yeah, okay. Why? What's the analogy? You guys are metal what again? Well, you're a piece of metal. So what is each one of you? The ion, the cation, the positive cation. Okay? What's moving in around you guys?
Wait, is it because like you told us that when something breaks, it's like the positives shifting over, so it's like positive, positive. But
Right.
since they're like electrons moving around, it can't. Is that it?
It's impossible to break because there's always an attractive force. Now, what am I trying to show you? What am I doing to the desk? Yeah. It's what? Give me a word to describe this motion.
Annoying.
I do stupid things and like dramatic things on purpose. I want you to remember it. It's supposed to be cheesy. What am I doing to the desk? Good, moving it. Give me some other words. This word's really important.
Adjust.
Shift and slide.
Sliding! Okay, now, why can metals...
That was funny.
Anyways, why can metals bend? Okay, because of what she said. That's really important. Because there's electrons all around you, if I move him over here, I move her over there, I move if we start moving you, you're still attracted because there's electrons all over the room. There's no braking involved here. But the word is sliding. Now, back to the boat analogy. Okay? Let's say you guys are all boats anchored next to a dock. You ever been next to a boat that's been next to a dock?
Yeah.
If it's, let's say it's kind of a smallish boat, you think you can push it a little bit? Why? Because it's on the water. Okay. So, why can metals bend? When there's a force applied, what do the metal cations do? Slide on what? The sea of electrons, just like boats in water. If you push it with enough force, it will slide. Does it break? No, because there's a constant force of attraction. So yes, that was very kind of silly and ridiculous, but that's what I want you to understand. Because the mobile valence electrons allow cations to, we could write the word glide or slide, whatever tickles your fancy there. Allow cations to slide on top of the sea of electrons. That's really important to understand. That's why I spent some time with the dramatics there. So when you take a hammer, or you hit a metal with enough force, so if I hit this row with a hammer, what happens is the entire row shifts. So now this one has moved, and now it's over here. But there's negatives over here too. They just didn't show it, right? I mean, there's more of these. So now this is gone. So this is the dent in the piece of metal. That's where the metal's bent or dented, whatever makes sense. If I keep hitting it, now this one's gone, and now it shifts again. But like Selim said, that was good. That was a good connection. It doesn't break because there's water everywhere. So all these negative charges that are over here will be attracted to the new cations you just pushed towards them. So everybody kind of just shifts and slides and glides, and they're still attracted to each other. That's a really big thing to understand. Okay, obviously I'm out of time. All right. No homework.